welcome. This is the second video where we will be talking about solving systems of linear equations using elimination. So we have a couple special cases to talk about. Let's get started. Special case number 1. Okay, so we're thinking about solving systems of equations using an elimination. I need to make sure both equations are written in standard form. And indeed, I got x plus y equals constant, x plus y equals constant. Great, standard form. I don't need to rewrite either of these. The next thing I need to see is, can I add these two equations together to eliminate one of the variables? And I can see, well, 3x minus 9x. Nope, not going to eliminate y plus 3y. Excuse me, minus 3y. Not going to eliminate. So I need to somehow adjust, multiply one of these equations, or maybe both, to get that elimination going. I can see 3 is a factor of 9. If I multiply 3 times 3, I'm going to get positive 9, and that will eliminate the negative 9. So I'm going to multiply this equation by 3, distribute the 3 to all the terms, and that equals 9x plus 3y equals negative 3. Alrighty, now I'm going to bring this equation right under, line up my variables. 9x plus 3y equals negative 3. I'm going to add these two equations together. Let's see what we get. I got a negative 9x plus 9x, and guess what? That's 0. That cancels. Here it goes. Here's the special case. I got a negative 3y plus a positive 3y. That also cancels. So this side of the equation is 0. And I have 3 plus negative 3, and that is also 0. And this is what I know. 0 does equal 0. This is always true, right? 0 always equals 0. So this is a special case of all real numbers. So since we've been doing this for a while and we know our special cases, we can imagine what special case number 2 is going to be, but let's see what it looks like. Okay, I have this standard form, xy equals. Don't need to rewrite. I do, however, need to get my variables adjusted so I can eliminate, because x minus 2x, not going to eliminate. Negative 2y plus 4y, not going to eliminate. I'm going to see that if I multiply a positive x times 2, I will get 2x minus 2x. So I'm going to multiply my top equation by 2 to get what I need to do for elimination. I got 2x minus 4y equals 2 times 5, 10. I'm going to bring that equation down here, line up my variables. 2x minus 4y equals 10. I'm going to add these two. Negative 2x plus 2x is 0, and here we go again. 4y minus 4y is also 0. So this side of the equation is 0. 2 plus 10, unlike over here, is not going to cancel out. I get 12. And no, this is never true. 0 does not equal 12. So this is our example of a no solution. No solution to these two linear equations. Alrighty, I am going to do these triad problems in this video, so let's take a look at these two. If you want to pause and try them yourself first, now would be a good time to do that. Otherwise, just listen along. Alrighty, solve each system using the elimination method. Okay, first thing I need to look, are these both written in standard form? First equation, x, y, constant. Yep, this one is not. I need to move my x over there. So I'm going to subtract x from both sides, and I will get negative x plus 6y equals 26. Now I can see that I have a 6y and a 6y, right? If I were to put this equation here, I can make one of these negative, so I can cancel out my y. So I'm going to multiply this equation by -1. And when I distribute across the equation, I get -1 times -x. That's positive x. -1 times positive 6y minus 6y equals -26. And now I will bring this equation, the top one that I haven't used yet, and add these two together. So I have plus 5x plus 6y equals 50. All right, let's combine them. I've got x plus 5x, and that equals 6x. -6y plus 6y cancels. And I have -26 plus 50, which is 24. To solve for x, I'm going to divide both sides by 6, and I get x equals 4. All righty, couple steps here, but my last step is to solve for y. I know that I got x equals 4, and as always, I can use either equation. I'm going to use that one. 6y equals 4 plus 26. 6y equals 30. Divide by 6, and y equals 5. So my solution is x equals 4, y equals 5, and I can prove my solution by substituting both of the values I solved for into the equations to prove that they make true statements, and they do. Next one. Okay, first step. Am I in standard form, both equations? Yes and yes. Do I have variables when I line them up that are going to cancel? No. -15 plus 5, not. 12 minus 4y, not. Alrighty, I've got to multiply one, and I can see that this is positive, that's negative, and if I multiply 5 times 3, I will get positive 15. So I'm going to multiply this equation by 3, and I will get 15x minus 12y equals 6. Now I will rewrite that equation here, and I will take the top equation and line up my variables. So I'm adding -15x plus 12y equals 11. Okay, 15x minus 15x is 0. Here we go. -12y plus 12y, that is also 0. And 6 plus 11 is 17, and this is not true. Never true. So this is a no solution. Alrighty. Last thing you might be asked to do in this unit is, which method, substitution, which we learned in class and or another video, depending when, or elimination, which is the more efficient method? Because as mathematicians, we want to be efficient. So let's take a look at each of these examples and decide. Okay. In this case, I have y equals 4 minus 2x, and that is written in slope-intercept form, and the y is isolated. I just want you to notice this. My second equation is in standard form. I can do either, but here's what I'm going to see. If I add 2x over here, I'm going to then have to multiply. What I have right now is already my y isolated. I'm going to use the substitution method here. I'm going to substitute this expression into this variable. Solve then for, I'm substituting into the wrong variable. Looking at x and thinking about x, so substituting it into the y because y equals that. So I will be solving for x, and then I will then solve for y. So what does that look like? I get 4x plus 2 times 4 minus 2x equals 8. Now I'm going to distribute, and I get 4x plus 8 minus 4x equals 8. All righty. Combining like terms. 4x minus 4x is, well, it's 0. So I end up with 8 equals 8. So just by using substitution, I am coming with an equation 8 equals 8. This is always true. I am already done. So this is in all real numbers. All real numbers. Alrighty, so there was that. The clear method was substitution. Let's take a look at our next one. I've got an equation written in standard form, 9x plus 2y equals 38, and a second equation written in standard form. So I'm leaning elimination. And what is really going to solidify that choice for me is that 3 is a factor of 9. So if I simply multiply this bottom equation by -3 to get -9x, I can easily eliminate the x's, solve for y, and then solve for x. So elimination is the more efficient method here. So let's do that. I'm going to distribute this -3. I get -9x plus 15y equals -21. I'll bring this first equation down, and I'm adding 9x plus 2y equals 38. When I combine these, I get -x plus 9x, 0. 15y plus 2y is 17y. 38, or -21 plus 38 is actually 17. I love when that math works that way, because when I divide by 17, I get y equals 1. Now I'm going to solve for x, knowing that y equals 1. And I can use either equation. Let's use this one. 3x minus 5 times 1 equals 7. 3x minus 5 equals 7. Plus 5 to both sides. I get 3x equals 12. I divide both sides by 3. And I get x equals 4. So, answer, x equals 4, y equals 1. I can use my answers, substitute them in here to these original equations, make sure I get true statements, and voila, I am done. Thanks for listening. That is all.